Right, the 12th question in kinetic theory of gases is the molecules of given mass of gas have RMS velocity. That means what is given? Given that RMS velocity, it is represented by V bar, okay, which is equal to what? 200 meter per second at what temperature? T1 is equal to 1.0 at temperature 27 degrees Celsius. 27. That means it is converted into Kelvin. It is added by 273. So in Kelvin, 27 degrees Celsius is equal to 300 Kelvin. And pressure is also given. It is called P1 is equal to 1.0 into 10 power 5 Newton per meter square. Okay, right. When the temperature and pressures of gas are respectively, now these temperature changes from 27 degrees Celsius to 122, 127, that means T2 is equal to what? 127 degree, that means T2 is equal to 127 plus 273 is equal to 400 Kelvin, isn't it? And pressure is also given. What is that? P2 is equal to 0.05 into 10 power 5 Newton per meter square. Okay, this is given. And what is the RMS speed? V2 bar is equal to what? So, how related this RMS velocity of gas molecule with temperature and pressure, which is obtained first? Okay, what is that? From kinetic theory of gases. What is that? The pressure exerted by the gas molecules on the walls of the vessel is 1/3 mn v bar square. Here n is equal to what? Number of molecules presence in the given sample. It is equal to n by v, number of molecules per unit volume, isn't it? Okay, therefore rearrange this equation. That implies PV is equal to 1/3 m into n is equal to what? N by v into v bar. That means this v is brought into this side. That implies PV is equal to 1/3 m n v bar square. This is equation 1. So from this equation we didn't have any relation between pressure, temperature and RMS velocity because there is no temperature term involved. So we can use ideal gas equation now. From ideal gas equation, PV is equal to what? N into R into T, isn't it? Now equating these two in terms of, okay, because PV is equal to this thing, here PV is also equal to this thing, but this is further modified. Here N is equal to N by N naught, number of molecules per Avogadro number is nothing but number of moles, and R is equal to what? Universal gas constant. R is equal to Boltzmann's constant into Avogadro's number, isn't it? Now you should further modify. Therefore PV is equal to N. N means what? N by N naught into R is equal to what? KB into N naught. KB into what? N naught into absolute temperature. So here N naught is cancelled. That implies PV is equal to N into KB into T. This is equation 2. Now from equation 1 and 2. What is that? Now from equation 1 and 2. From equations 1 and 2. What you can write? What is first equation? PV is equal to 1/3 mn v n bar square. That means 1/3 m into n into v bar square is equal to, what is that? nkBT. N into Boltzmann constant into absolute temperature. So here on both sides Nn is cancelled. Then you should rearrange this one. M into v bar square is equal to 3 into kB into T. That implies v bar square is equal to 3 kBT by m, isn't it? Now in this expression, RMS velocity square is equal to 3 kBT by m. That means from this RMS velocity square is directly proportional to absolute temperature. That means in this relation there is no pressure term is involved. Therefore V1 bar square by V2 bar square is equal to T1 by T2. Already all values are there. V1 is given, what is that? 200. That means 200 square by V2 square is equal to T1. How much? 300 Kelvin by T2 is equal to what? 400 Kelvin, isn't it? That implies V2 square is equal to, these two are cancelled. Then V2 square is equal to what? 4 into 200 square by, what is that? 3. Okay, that implies V2 bar is equal to, when you take root, so 2 into 200, that means root 4 is equal to 2, root 200 square is equal to 200 by root 3. That implies 400 by root 3 meter per second. That's it.